This next video, as you can see, we are going to be looking at parallel and perpendicular lines, and particularly the gradients of those particular scenarios that you might come across. The first one that I want to look at is parallel lines. Obviously, just reviewing what parallel lines are, they are two lines that, as you can see, will never actually meet. So the distance between them will always be exactly the same. Now, I've drawn two parallel lines here. I've just made two up, I guess, but as you can see, they are parallel. It looks like that they won't ever meet, and this distance between the two of them, so I'm referring to this distance here, or this distance here, will always be the same. Now, in terms of the gradients, there is one special thing about parallel lines, and that is that they will have the same gradient. Now, as you can see, it makes sense, doesn't it? Because they do share the same slope, the same steepness. Obviously, if one was more steep than the other, then eventually at some point they would meet. As an example, if I just turn this into a line, say I had a line here and it had a slightly steeper gradient than the yellow one above it, of course that means at some point, there it is, they're going to meet. Parallel lines, however, exactly the same gradient. And I just want to demonstrate that for you now. We've just done a little bit of finding the gradient. So for this first one, the gradient, I'm going to call, I'll just get rid of my updates because I don't really want to do that right now. I'm just going to call the gradient m. So the gradient here would be 6 minus the 3, so that's the difference in the y's. 4 minus 1 is the difference in the x's. So I've got 3 over 3. That's a gradient of 1. For this one over here, the difference in the y values is 4 minus 1, and the difference in the x's 4 minus 1. So of course we also get 1, or 3 over 3, which is 1. So as you can see, the two parallel lines that I've drawn here, they have the same gradient. I wanted to show you this with a few more. As you can see, I've got here exploring parallel and perpendicular lines. I might just zoom in and out a little bit. As you can see, this is an applet, and it's pretty cool because what I can do is I can move these lines around. So what you'll see is I've got one line here and the slope is shown 2 over 2 or 1. Same with the slope of the first line. Now what I can do is just drag them. As you can see, I've moved the two lines, but what do you notice? They're still parallel, obviously. The slope 1 over 2 and also 1 over 2. So I can spin these around however I like. Now it's negative 1 over 2. I can drag that one, drag them further apart even. They're vertical at the moment. They're both undefined, or drag them around to there. There we go. They're both negative 3. So no matter what you do for them to be parallel, they will have exactly the same gradient. You can then use that to answer particular questions. Oops, I've gone to the wrong slide there. That's from a previous video. Go back to this one. You can answer questions like the one underneath. So you see that there's two coordinates, A and B, and you want to show that it's parallel to this particular line interval PQ. Now to do that, to prove that they're parallel, what you need to do is show that they have the same gradient. So I'm going to do that now. The gradient of AB, so that's these two coordinates here, difference in the y's is going to be 11 minus the 4. Difference in the x's is going to be 7 minus the 6. Now, of course, that is 7 over 1, or 7. For that to be parallel to PQ, it has to have the same gradient. So let's check that. Difference in the y's, well, that would be 7 minus 0. Difference in the x's, 1 minus 0. So, of course, we have 7. So by doing this, I've proven that they are parallel. Same gradient, parallel lines. You can also do the opposite will be true. If you are given two lines and you're told that they have the same gradient, then you can make the assumption that, yes, they are parallel. The second one I want to show you is the opposite to parallel lines in a way. They do touch, lines that do touch. But they touch at a particular angle. I'm going to take off parallel lines at the moment from this applet. I'm going to put on perpendicular. Perpendicular lines mean that they have a 90-degree angle between them. So this red line here and the black one that I've got highlighted right now, there is a 90-degree angle between them. So it creates, I guess, like a perfect cross. Now, what I want you to do is have a look at the slopes of each of these and see if you can notice anything. The slope of this red one is -3. The slope of the black one is +1/3. So you may not notice anything just yet. What I'll do is I'll spin it around a little bit and notice what happens. Maybe to there. The slope now of this black one here the red one is +2 because it's -2/-1, so +2, and this one is now -1/2. What we should be noticing is that these are negative reciprocals. Now that's probably a weird word that you've never heard before. What I mean is one of these lines will be positive and one of them will be negative. So you'll see here this one's positive and this one over here is negative. But they're also what we call reciprocals. So can you see how this slope is 2/1 and this one here is 1/2. It's also negative as well. So see how the numerator and the denominator have flipped. If I switch this around, find another one. Here's one here. This is 1/3 as opposed to 3/1. And you'll see this one here is negative, this one here is positive. There's another way to look at this, and that is if we multiply together the slopes of perpendicular lines, we're always going to get a particular value. So -1/3 multiplied by -3. Sorry, for +3, because this is a negative over negative. It would be handy if they did cancel that out, but anyway, -1/3 by +3. When you do that, and you do that with any of these combinations, such as this one here, so this would be 2/2 is 1, so this is -1, and this is +1 here. When you multiply them together, you will always get a particular value. Just find my slide. There it is there. The perpendicular lines, I mentioned that their gradients are that thing negative reciprocals. I'll write that in a minute. But the second point is that they will always multiply to give you -1. Always. They are negative reciprocals. I'll write that word for you. And we'll have a look at it in terms of this example. There's a drawing of perpendicular lines, like I was saying. There's a cross, they form a cross, but in particular, we want that 90-degree angle in there. We want to show that these lines here are perpendicular. So really what we want to show is that the gradients of each, when you multiply them together, will give you -1. So let's first find the gradient of AB. So AB gradient. Might split this into like I normally do. Just pick a colour and just like so. Alright, so I'll go back to doing the gradient. What have we got here? Difference in the y values. We have got 12 minus 0. Difference in the x values, 0 minus 6. So we have 12 over -6. So we've got -2 for that particular gradient. Let's have a look at the gradient of PQ. Again, difference in the y values. As you can see, we have 8 minus 10. I might just move that over so I don't a bit more space. And difference in the x, 4 minus 8. So 8 minus 10, we're going to get -2. 4 minus 8, we're going to get -4. So when we cancel out the negatives and simplify, we've actually got 1/2. So the reason that we know these are perpendicular is if we take the gradient of each, so the gradient of AB is -2, and if we multiply that by 1/2, what you should find is that we get -1. So we've got -2/2 when you multiply it, and that is equal to -1. And what we can say from there is that therefore AB and PQ are perpendicular. I know that as soon as I find the product of their gradients and it is equal to -1, I know that this is true. Just like if I was shown this, and I was to make a statement about the lines, I could say, yep, I can see that it's -1, they therefore must be perpendicular. I was saying before that they're negative reciprocals, so again, let's check this. If we've got, I might just open a new slide actually, so I've got some more space. There we go. My two values, just to fix that. My two gradients, they were 2 and -1/2. So remember, this is 2/1. So by negative reciprocals between these two here, what I mean is you can flip the 2/1, flip it, and you get 1/2, and then change the sign. If I do that, flip it and then change the sign, you can see I get -1/2. So therefore these are negative reciprocals. So if you had, say, 5, negative reciprocal, -1/5. If you've got a gradient of 2/3, negative reciprocal, -3/2. And what you should find is if you multiply these together, you find the product, it will always be -1. So I'm going to leave it there. You will have a bit of a go after you've tried some of the gradient questions, having a go at looking at the parallel and perpendicular lines. And these are going to come up again later when we're doing the equations of lines as well. So it's a really important skill that we need for this particular topic.